Hey everyone, and welcome. Today, we're diving into a huge puzzle that companies grapple with every single day. How do you get your products from point A to point B for the absolute lowest cost possible? It's a massive challenge in logistics, so let's get right into it. So, to get us started, let's picture a company. We'll call them the XYZ company. Pretty simple setup. They've got two factories making widgets and three warehouses that need to be stocked with them. Seems straightforward, right? Well, this simple setup leads to a really big question. And there it is. This is the million-dollar question for any logistics manager out there. I mean, it sounds easy enough, but finding the perfect answer, the absolute cheapest route, can save a company a ton of money. Now, this puzzle actually has a formal name in the world of operations research. It's called the transportation problem. It's basically a special kind of math problem where the entire goal is to slash the total cost of moving stuff from your sources, like factories, to your destinations, like warehouses. Okay, so this is what it usually looks like on paper. It's a grid, or a matrix. On the side, you see your sources, Factory 1 and Factory 2, and how much they can supply. Across the top, you've got your destinations, the warehouses, and how much they need. And all those numbers in the middle, that's the cost to ship one single item from that factory to that warehouse. All right, so how do you even begin to crack a puzzle like this? Well, before we jump into the messy real world, let's take a look at how this all works in a perfect world. And there's a really great analogy for this. Think of your whole supply chain like a big water tank. In a perfect scenario, the amount of water flowing in, that's your supply, is exactly the same as the amount of water flowing out. That's your demand. Nothing overflows and the tank never runs dry. It's a perfect match. And when everything lines up perfectly like that, it has a name, a balanced transportation problem. It means every single widget that gets made has a home to go to, and every single warehouse gets exactly what it ordered. No extra stuff, no one left short. But let's be real. Business almost never operates in a perfect world, right? Life is messy. Supply chains are always changing, and things are rarely in perfect balance. So, what happens when things get out of whack? That's when we run into what's called an unbalanced transportation problem. And it's exactly what it sounds like. It's any time your total supply does not equal your total demand. Let's look at the numbers. In this example, see how the factories can pump out a total of 850 units? But if you look at what the warehouses actually need, it's only 700 units. The numbers don't add up. 850 does not equal 700. That, right there, is a classic unbalanced problem. So this imbalance is a big deal because it means the standard ways of solving this problem just won't work. But luckily for us, there's a really clever and surprisingly simple trick to fix it. I mean, how can you possibly find the cheapest routes when you've got more stuff than you have orders? Or maybe the other way around. How do you make the math work when the two sides of the equation just don't match? Well, the solution is this really neat little hack, and it's just two steps. First, you figure out the exact difference between your supply and demand. Then, you create a fake place, a dummy location, to take care of that difference. And boom, here's exactly how it works. Remember we had 150 extra units of supply? So, we just add a new column for a dummy warehouse. This make-believe warehouse has a demand for exactly 150 units, and here's the trick, the cost to ship there is zero. Just like that, our total demand magically becomes 850, it matches our supply, and the whole problem is balanced. Pretty cool, right? And what's so great about this dummy trick is that it works both ways. If you have too much product, the dummy destination is basically a virtual storage unit for your extra inventory. But if you have too much demand and not enough product, you can add a dummy factory, and that represents all the orders you just can't fill. It's just a clever way to make the numbers work, no matter the situation. Okay, so we've used our dummy variable to get everything back in balance. Now the problem is solvable. So what's next? Well, now we can actually find the cheapest shipping plan. And that's the key thing to remember. Balancing the problem isn't the final answer. It's the critical first step that lets us find the answer. It sets the stage so we can use these powerful methods to come up with a really good first draft of our shipping plan, which we can then fine-tune. Now, we're not going to get into all the crazy math here, but once it's balanced, there are a few popular ways to find that initial plan. You've got things like the least cost method, which is super intuitive. You just start by shipping on the cheapest routes first. Or you have more advanced methods like Vogel's approximation, which is a bit more complex, but usually gets you a lot closer to the absolute best solution right from the start. Okay, so we've done the math, we've balanced the problem, we've found a shipping plan. So what? Why does any of this theory actually matter in the real world? Because it all boils down to this: a real number. After you run the numbers through one of these methods, you get a concrete answer. A company can find out that the absolute, rock bottom lowest cost to get everything where it needs to go is, in this case, exactly $420. No guesswork. And that's the whole point. This isn't just a math problem on a whiteboard. It's a seriously powerful tool that real companies use to make huge decisions. We're talking about optimizing their entire supply chain, managing inventory better, and saving a whole lot of money in the process. Which, of course, leaves us with one last thing to think about. For years, this has been a classic logistics puzzle. But today, we're in an age of AI-powered logistics and instant gratification. The game is changing fast, so you have to wonder, what's going to be the next great transportation puzzle we have to solve?